Welcome to 4.5 Exponential and Log Equations, Part 2. Today's focus is going to be on log equations. So let's just recall the one-to-one property, meaning if I have log base b of x equals log base b of y, since I have log equal log and the bases are the same, we can zoom in and say those arguments can be the same or are equal, so long as each argument is positive and each base is positive and the base cannot be 1. Okay, so the first scenario that we're going to look at for our examples is a log equaling a log scenario. So the rule of thumb is there can only be one log term per side. If there's multiple, so log plus log or log minus log, we have to condense. And always, 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 at the end, we have to check our answers to make sure that our arguments will remain positive. Okay, so let's take a look at this first example. We have log of 3x minus 1 equals log of x plus 7. Now, there are no bases that are written in, so remember, if there's no base, it's a base 10. Okay? All right, now we didn't need to write that, but since we have one log on each side, what we can do is we can zoom in on the arguments and set those equal. So the logs don't just go away, we're just zooming in on part of the equation. So if the log and the bases are the same, we can go ahead and zoom in. So now we go ahead, 3x minus 1 equals x plus 7, and we go through and we solve. Now when we check our answers, we can go ahead and see, all right, well, when x equals 4, for this portion here, I get 12 minus 1, which is 11. Okay, that's positive. And when I check in here, we get log of 4 plus 7, which is 11. So we get those positive arguments there. Did you need to show that? Not necessarily, but you do need to check in your head. This next example, again, it's a log equals a log, all right, or log equals multiple logs. All right, now notice this time we have natural log or log base e, all right, doesn't change the game, but I notice on the right side here I've got two log terms, right? So what we need to do is we need to condense these. Now, how do we condense two log terms when we're adding them together? We multiply the arguments. So really we take 2x plus 2 times x minus 2, we multiply those out, and we have one log term. So it becomes the natural log of, when we multiply those two arguments together, we get 2x squared minus 2x minus 4. So now we have a log equals a log. Both the logs have the same base, okay? So now we do our zooming in. So now we can say 3x plus 8 has to equal 2x squared minus 2x minus 4. So now we're going to go through and solve this equation, and what we should notice is we've got ourselves a quadratic. So we're going to bring everything over to the right side, all right, and what we can do is we can try to factor that. 2x squared minus 5x minus 12, it does in fact factor, so it's going to be helpful to go through and remind yourself of how to factor quadratics, okay? We get two answers, okay? We get x equals negative 3/2 and x equals 4. But what you should see is I crossed out this x equals negative 3/2. Why? Because if we were to plug these back in, negative 3/2 times 3 is negative 9/2 plus 8. Well, that part works. But if I look over here, negative 3/2 minus 2, this is a negative argument. We can't have negative arguments, so we throw that one out. It's called an extraneous solution. When we test 4, when we plug 4 into this argument, it's positive. 4 in here, we get a positive argument, and we get a positive argument here as well. So 4 is our only answer for this question. The next scenario, or scenario number 2, is when we have a log equals a number. Okay, so we still can only have one log term per side. So if we need to condense, we can condense. After we have the scenario where it's a log equals some number, we then convert to exponential. Okay, so let's look at our first example within this type. So if we take a look, we have log base 2 of 9x minus 1 equals 5. This left side is completely condensed. I only have one log term. So now we can go ahead and convert. So remember, when we convert, we identify our base, we raise it to the other side, and we set it equal to that entire argument. Okay? So we get 2 to the 5th equals 9x minus 1. Well, 2 to the 5th is 32. So 32 equals 9x minus 1. We go through, we solve, we get x equals 33 over 9, which of course simplifies, so make sure you're simplifying these fractions. If we were to plug that in for x here, we would still get a positive argument. So x equals 11 thirds. It works out. This next example, I have a log term on the left, but I have a number and a log term on the right, okay? And they're adding or subtracting. In this case, we're subtracting those two. So I want all of the logs on one side. So I'm going to add the log of x plus 15 to the left side. So here we have log of x plus 15. So now what we need to do is we need to condense this, okay? So we want to condense that left side so we only have one log term. So since we're adding these two log terms together, we're going to then multiply the arguments. So we end up with x times x plus 15, and that's where we get this left side. Log of x squared plus 15x equals 2. So now we've gotten to the point where we have a log equals a number. So we can convert to exponential. Now remember, if our base is not written in, what is the base of this log? Well, no base, that tells us it's a base 10. So now we can convert. So we identify the base, we raise it to the other side, we set it equal to that argument. And we get 10 squared equals x squared plus 15x. Well, 10 squared is 100. So I just subtracted 100. Okay, and now we have 0 equals this quadratic, x squared plus 15x minus 100. We can factor this out, x plus 20, x minus 5, and we get two answers. But why did I cross out x equals negative 20? Well, if we look back at the original and I plug negative 20 in for that argument, that's a negative argument. We cannot have negative arguments, so therefore negative 20 is extraneous. Does x equal 5 work? Well, when I plug into log of 5, that works. And 5 plus 15 is 20. That produces a positive argument. So x equals 5 certainly works. This last example is a little trickier because we have a log within a log. So the way I would say this is log of the log of x equals 2. So we essentially, if I kind of highlight this portion here, we look at just this portion, log of something equals 2. We have a log equals a number scenario, okay? Now, the base of this initial log is a base 10. So we identify the base, we raise it to the other side, and we set it equal to that argument. So that's where we get 10 squared equals, our argument is log of x. Okay, well 10 squared is 100. Equals log of x. Well, we still have a log equals a number scenario, so what do we have to do? We have to convert one more time. The base of the log isn't written in, so I know it's a base 10. We identify our base, we raise it to the other side, we set it equal to that argument, and we're left with 10 to the 100th equals x. Now, if we were to throw this into our calculator might very well scream at us. You might have to listen carefully. But we can leave our answer as 10 to the 100. That's a 1 with 100 zeros. That's quite a lot. All right. If you have any questions, let me know. Have a good night.